So, hello. I think I am audible now. So, yeah, yes. So, let's start with the today's session actually. Now, yeah. So, I'll be going with the graph session today, right? In between, if you have any doubts, please let me know, right? So, firstly, let me introduce you what a graph actually is and where do we use a graph. So the first thing will be, what is a graph? Finally, you are back. Thank you. Thank you, Vikas. Thank you for commenting. Uh, so thanks for being in the live session. Right. So what is the graph actually? How, do you have any idea about the graph? So before that, let me tell you, there is something like a city here, a city. Let me call it as Hyderabad, and there is another city like Chennai here, Chennai, and there is another city like Bengaluru. Okay. Now, there will be road connecting from Hyderabad to Bengaluru and Bengaluru to Chennai and then Chennai to Hyderabad. So first thing, I'll tell you a clear distinction, right? So Bangalore to Hyderabad, I am making a one directional, right? Just like Bangalore to Hyderabad, a one-way road, something like that. And from Hyderabad to Bengaluru, also, if I have a road, something like in a road, we'll be having something like a dividers, and here we'll be going from the left side. So here it will be Hyderabad or Bengaluru here, right? So the road is nothing but bidirectional. Let me say this as bidirectional. Now I am having the same thing for every road. Every road is having the same thing. Now, for some areas, there will be something like a ghat sessions, ghat roads for some hills. If you see, those will be one way. I'll tell you what is one way means. Like if you remember for in a guard session, bottom and top of the hill. So we will be having only one route, one way, which is nothing but a unidirectional. Let me tell you, this bidirectional means this edge. I'll tell you, this edge is nothing but a road. So every city, every city is named as a node, and every road is an edge, right? Edge can be bidirectional or unidirectional, only one way or both the ways. Now, is there anything which I am missing? Let me tell you another thing. What is the distance between Hyderabad and Bangalore? Let me ask here. Between Hyderabad and Bangalore is 567 to 581, and Hyderabad to Chennai, let us say that 567 from Hyderabad, so 600, and Chennai, is there anything? Chennai and Bangalore, so it is 300. Okay, so Bangalore to Chennai, it is 300 kilometers. 300 kilometers. It is something like Bangalore to Hyderabad, it is 5. 60 kilometers, and here it is 600 kilometers, right? What if I say this is the distance between the cities? Now, if I construct something like a graph out of this, I'll be having like this. This, let me say that as 0, 1, and 2. I'm just numbering the cities or the nodes. So 0, 1, and then 2. And here I'm saying that it is bidirectional. Nothing but there will be, you can go from 1 to 2, 2 to 1. Nothing but Bangalore to Chennai or Chennai to Bangalore. There is two-way roads, right? And from Bangalore to Hyderabad or Hyderabad to Bangalore. We have both the routes. Or from Hyderabad to Chennai and Chennai to Hyderabad. Now I'm saying the weight is something like 560 here and 600 here and 300 here. So it will be something like the distance. I'm saying it as the weight. Today we'll be just having a session on the basics and also some of the problems we'll be solving, right? So we have covered one thing, the Hyderabad or the city as a node and the road as an edge, and also we have know what is a unidirectional, nothing but one-way road, what is bidirectional, nothing but the two-way road, and also the distance we are naming it as the weight of an edge. Now, is there anything which I have uh, missed? Will be like if I am at node 1, we'll go to the nodes instead of the cities. From node 1, I am going to node 2. Then I am going to node 0. Then I am going to node 1 and then 2 and then 0, 1, 2, 0, 1, 2, 0, and so on. If you see here, if I am having only one directional edges from 0 to 1 and then to 2 and then to 0. So this will form a cycle in graph, right? There will be questions again on how to detect cycles and also topo sort and also searching algorithms to search an element. But let me tell you how we can go with problems. I think we can finally go to the problems or the concept of DFS and BFS, right? And if you have any doubts, please let me know in the chat box. It's just a very less or the basic explanation of graphs. So this will be in maps, mostly used in maps and also in computer networks, computer networks. I'll tell you one example of computer networks. So if you are in a big city like this, you are here and you are calling someone or you want to have this internet connection. Now, there will be some towers or service providers, something like that. So this, from this, if you see, these are some of the towers or service providers. So from this, the one which is nearer or the one which you can or this server which can be the shortest length or the path will be connected to you, right? So the shortest path algorithm, or we can say that as Dijkstra algorithm, will be implemented here. So the Dijkstra algorithm, we can also say that as shortest path algorithm, right? So if you have any doubts, please let me know. right? So the Dijkstra algorithm will be used when we are going in Google Maps, where we find the shortest path every time, right? So I think we are clear about the Dijkstra algorithm, just an introduction about the graphs and where we'll be using this graphs concept. Now, let us go with the depth first search algorithm. I'll just explain the depth first search and also the breadth first search algorithms. Then let's move into the new concepts or just solve one or two problems on it. First, depth. Let me not write anything about the algorithm. Let me tell you how does the working will be 0, 1, 2, 3, 4, 5, 6, and then 7. Yes. What will be the case like all all the edges are bidirectional? Print print the nodes. That's it. I don't know which algorithm we might use here, but we need to print all the nodes, right? So we need to print all the nodes. Now, if you are new to our channel, so this channel, we are having, let me tell you how many subscribers we have? 917 subscribers. That's, yes. Where is, okay, I think I need to go to the Creator Studio here. Switch on YouTube Studio. Yes, here. So we are just 13 subscribers less to hit 1000 subscribers. Let me see. Analytics. It's been a month I have opened these all subscriber count and all. So yeah, from 23rd Jan or yeah, from the 23rd Jan, I think it's been 5 days. Okay, let's see. Now, print the nodes is nothing but how many nodes we are having, all the values of that nodes, right? How can we print it? So the first thing, let me go to 0, and 0 is connected with 1 and also 2, right? So 0 is connected with 1 and also 2. Now, from this 0, I will go to 1 first. So my pointer is at 1. Now this one is connected with 3 and also 4, right? So this one will go. Let me go to 3. Now this 3 is not having any children or having no node which is unvisited. Let me tell you what unvisited means. So this node 0 is already visited. This node 1 is also visited. This node 3 also visited. Now I'll go back to 1. Then for this one, is there any node connected with 1 and not visited? Let us say that as not visited. So yes, I have 4 which is not visited. So let me go to 4 now. So my pointer is at 4. Then does 4 have any node which is connected with 4 and not visited? So There is no node which is connected with 4 and not visited. So from 0 I went to 1, from 1 I went to 3, as 3 is not having any neighbor nodes which are not visited. I'll go to 1 and I'll check whether 1 is having any nodes which are not visited. I'll go to then return to 0. Okay. Now I have this 2. So I'll go to 2. Then I have 5 and 6. So I'll go to 5. Then this 5 is having 7. So I'll go to 7. Now this 7 is having no neighbor which is not listed. So I'll return. Then 5 is having no neighbors which are not listed. So 5 again returns to 2. So 2 is having 6, right? So 6 will be listed. And 6 is not having any node which is not listed. So return again. So 0 will stop here itself, right? So what are we doing actually? Going to the depth. So we just go to the depth and visit the nodes. So the order which I got the nodes is 0, and then I went to 1, and then I went to 3, and then went to 1, and then 4, then from 4 to 1, and then to 0, 0 to 2, then 2 to 5, then 5 to 7, then 7 to I'll go to 5, and then 2, and then get 6, right? So this is something like uh, which we mark the nodes every time as visited or not visited. Firstly, every node will be marked as not visited. As soon as we visit the node, we mark them as visited. I'll tell you. First, we will make a visited array of size. The number of nodes which we have in the graph is nothing but n. So everything will be visited. Is it visited? No, false. Is it visited? False. False. And false for n minus 1. 0 to n minus 1. Everything will be false. As soon as you visit a node, you make it as true. If you visit, for example, if you visit node 2, then visited of 2 will be made as true. That's it. That's how simple it is, the DFS algorithm. But when it comes to problem, they don't just ask you to implement DFS or just ask you to implement BFS. They ask you in another ways, the number of islands, max area of an island, something like this, and also topo sort and Dex all of them. They don't simply ask you what is the just print the votes by implementing the TFS. That's a super easy problem. You don't get those things in interviews. No. Going to depth, as I said, we go to the depth of the DFS. Let me write a function. First thing, first thing, you have the DFS, the node which you are visiting. That's the first thing. You have the node and also the array, visited array. Is there anything which we are going to look at every time? I think the adjacency list. Yes, adjacency list. I'll tell you how does this adjacency list will be. There will be adjacency matrix, but many of the times we don't. use this adjacency matrix even. So the adjacency list, what does this mean? So from 0 to 1, if I have a bidirectional edge from 0 to 1, so adjacency list of 0, you see, adjacency list of 0 dot pushback. I'll tell you how I'm implementing pushback 1. Nothing but for 0, I'm having 1. Imagine I have a 2 here. Then adjacency list of 0 dot pushback 2. Nothing but we have a 2 also here. Now, this one is having an edge with 3. It is a bidirectional. So adjacency list of 1 dot pushback 3. And if you see for 1 also, for 1, 0 is also connected with 1. You can go to 0 from 1. So for 1 we'll be having 0. So for 2 you can go to 0, right? For 2 you can go to 0. From 1 you can also go to 3. And from 2 you can go to 0, and from 3 you can go to 1. From 3 you can go to 1. I think it's quite clear. So adjacency of 0 dot pushback 1, and also adjacency list of 1 dot pushback 0. Adjacency list of 0 dot pushback 2, and also adjacency list of 2 dot pushback 0. Nothing but it's a syntax in C++. Now, if you visit node 2, then all this. Now, we have the node and the visitor and also the adjacency list. First thing, we'll just change visitor of node as true. That's the first thing. Now for this adjacency list of the node, we are having some neighbors, right? So I'll go there for auto neighbor of this adjacency list of node. Nothing but what is this neighbor of adjacency list of node? Just imagine the node as 0. So the node is equal to 0. So I am starting the iteration of the graph traversal from 0. Then I can go to 1 and also 2. That's present here. So that's why this adjacency list will contain the elements 1 and also 2. The 0 contains 1 and 2. So neighbor is nothing but will go to 1, and the neighbor is nothing but will be like an index assigned to 2, right? So 2 will be assigned to neighbor or 1 will be assigned to neighbor. So for auto neighbor of adjacent list of node is nothing but we are iterating this list where the node is connected with the neighbors of the node indirectly. No, I'm going to every neighbor, right? First thing, if I go to the neighbor, first thing, it should be unvisited. So if neighbor is unvisited, so visited of neighbor is equal to false, then only I visited, right? So DFS of neighbor visited and adjacency list. Is there anything which I am missing, right? I think it's clear for you, and if you have any doubts, please let me know. So there will be a short break here itself. Yeah, Shiv, that actually works, right? That's a good one. Join the journey to 1K subscribers. Yeah, thank you for your suggestion. So if you are having any doubts regarding the DSS algorithm or anything about a problem related to graphs, please let me know in the live chat. So yeah, I think we are ready to go with applying the same DFS concept here, number of islands. So the first thing, let us look at what is given to us. The number of islands, the problem name is just the number of islands. The problem number, let me lead code 200, number of islands. Let me pin this comment, pin, yes. Now we can go with the problem. Given at m by n 2D binary grid, which represents a map of ones, land, and zeros, water. So 1 means land, 0 means water. Return the number of islands. The number of islands. We just need the number of islands, right? What will the island look like? A land which is surrounded by the four direction or all the directions which is surrounded by water. An island is surrounded by water and is formed by connecting adjacent lands horizontally. Oh, sorry, horizontally is like this and vertically. You may assume all four edges of the grid are all surrounded by water. What what they are saying is, so there is some water like this. There will be some water. First, let's take this four ones and then zero. Okay, first four ones and then a zero and double one zero one zero double one zero one and then zero double one and remaining all are zeros. One one, so the remaining are zero 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 zero. So this is the grid which is given to us. So what is the only island I can see? And also you can see, right? So this is the grid given to us, and the four direct or the these edges are also surrounded by water. So it is surrounded by water. Now, what is the only one piece of island which you can see is this one island, and we'll just return one there itself. Now, double one triple zero, double one triple zero. So double one triple zero, double one triple zero, and then double zero one double zero, double zero one double zero, and triple zero double one. Now the remaining are zeros. Three times, two times here, two times here, zeros here. Now this is the grid. It is surrounded by water. It is surrounded by water. No, okay. These surrounded by water. No. What are the number of islands? This is the first island. You might ask me, this will be an island, right? No, it's not like that. The island is connected with the land horizontally or vertically, not in a diagonal way. So this is an island, this is an island, and this is another island. How do you get the number of islands? So totally three. So if I start my iteration or traversal from here, I'll go here 1. I'll just mark it. This one is also marked. So if I go to the right, I saw a 0. If I go to the top, there is no, uh, it is out of the grid, right? Out of the boundaries. If I go to the left, it is already visited. If I go to the bottom, I got 1. Now, this is also, I just visited. Then I'll go to left, this visited. Now, I started with this one and got these all. Nothing but this is just a piece of land. Then I go to 0. It is water, so I just skip all these things and also this one, and I go to 1 here, make it as listed, go to top, water, skip, go to right, water, skip, go to bottom, water, skip, go to left, water, skip. So this is one piece of land again. So every time I see a land not visited, I will increment the count, right? I'll just increment the count. That's it. Then I'll go to waterscape. I have a land. I'll just increment the count. What is the count for now? 3, right? So it was 2. When I increment by 1, I got the count as 3. So I'll just mark it as listed. Go to top, water skip. Go to left, water skip. Go to bottom, out of boundary. Go to right, I got a land, mark it. Then from this, go to top, water skip. Go to left, visited, skip. Go to bottom, boundary, out of boundary, skip. Go to right, out of boundary, skip. So our iteration, this iteration, how do I go for this iteration? So for int I is equal to 0, I is less than number of rows. How many number of rows I have? Let us see the number of rows m by n. M is the number of rows and I plus plus. Then for int j is equal to 0, j is less than n, j plus plus. I'll just ask for the DSS. But before that, if visited of I j is equal to false, if it is not visited, and grade of I j is equal to 1. I think they have given it in string, sorry, a character. Yes, I've solved it for 2 times previously, so I just remembered it. So if it is not listed and it is a piece of land 1, then I'll increment my count first, then call for DFS and make all the surroundings or the neighbors which are connected with this land as visited. DFS, I'll call this with the grid. What is the I? What's the column? J and grid IJ, and I have visited uh, grid again. Is there anything which I am missing? No, I got the node, I got the visitor, and I also got the grid. I think no. Now, how do I write the DFS? Previously, I wrote for a node. Now I need to write for a row and column. So in the TFS, I have this grid and also row and column. I'll just say that as row and column, and I have visited. Now, as soon as I get it, visited of row and column will be made as true. Now, every time I'll be having check the right, the left, and the top, and also the bottom. For that, I'll be having the directions. Directions is equal to 0, comma 1, 0, comma minus 1, minus 1, comma 0, 1, comma 0. So all these are the directions. Now in the DFS for auto x comma y in directions new x is equal to row plus x, new y is equal to column plus y. First thing, it need to be in boundary. First, if new x is greater than or equal to 0 and new x is less than m and new y is also greater than or equal to 0 and new y is less than n. What does this mean? I'll tell you. If you are at a place here which is 1 and if it is the first element, you cannot go top. Nothing but this is 0 comma 0 and you are going literally where you are going. I'm going, this is 0 and then this is 1, this is 0 and then 1. Here it is just minus 1. The row is minus 1 and the column is same 0. So the top row is minus 1 and the column is 0. What about the bottom? So the row will be incremented 1 comma 0. What about the left? The row will be the same but the column will be decremented. What about the right? The row will be same but the column will be incremented. Minus 1 0 I wrote it here, minus 1 0, 1 0 I wrote it here, 0 1 minus 1 here, 0 1 here. So now I got a new x and new y is also what do you say, in boundary, and it needs to be grid of new x, new y needs to be 1. That means it should be a land. Then I will call for DFS of the grid new x, new y, and visited. That's it. So this is how we solve this problem. And so where do I? Yes, here submissions. I have this, yeah, a DFS grid of row column. Let us so if you see here, instead of using any visited grid, I'm just using the grid itself and making the visited cells as 0. Let me tell you with, yeah, here, yeah, that's the same thing. I have here. Now in this DFS, so new row and new column, it's the same thing with the auto iteration. So I think you're clear with the today's session, and it's just a simple DFS which we have discussed today. And if you have any doubts regarding this, the problem or the algorithm or the graph concept, please let me know in the live chat, right? That would, yes, ask the doubts in live chat.